Welcome back to our second part of the video, which is solving trigonometric equation. At the end of this presentation, you should be able to solve trigonometric equation, apply the concept of reference angle in solving trigonometric equation, and solve worded problems involving trigonometric equation. Before we proceed to the lecture proper, we need to differentiate trigonometric equation from trigonometric identity. When we say trigonometric equation, these are only limited to a certain solution or certain values, while trigonometric identity, the values may be an infinite number. Also, we need to recall the sign of each angle and the concept of reference angle as discussed in your module number 1. The signs for each angle is very important in determining now the values of your trigonometric equation. That is, in quadrant 1, please take note of this one. In quadrant 1, sine, cosine, and tangent would be positive, while in quadrant 2, sine is positive while cosine and tangent is negative. In quadrant 3, only tangent is positive. The rest would be negative. While in quadrant 4, cosine is only positive while sine and tangent is negative. To make use of this one, I'll give you an abbreviation of A, S, T, C. What does it mean? In first quadrant, all are positive. In second quadrant, only sine is positive. In third quadrant, tangent is only positive. And in quadrant 4, cosine is positive. Please take note of this concept or this abbreviation as we will be using this one in the succeeding lecture. Also, in module number 1, we discuss the concept of reference angle. Reference angle are the smallest positive acute angle with respect to the x-axis. Please take note of the concept that in the first quadrant, the angle itself would be the reference angle, while in the second quadrant, you may get that one into 180 degrees minus the given angle, while in the third quadrant, that would be the angle given minus 180 degrees, and in the fourth quadrant, we have 360 degrees minus the third or the given quadrant. Please take note of these two important concepts as we will be using this one in the succeeding lecture. In solving trigonometric equation, these are the following things to remember. First, you determine if you are looking for a general solution or a solution over a specific interval. In this case or in this lecture, we will just focus on the solution over a specific interval. Second, regardless of whether or not you are looking for a general solution or a solution over a specific interval, as soon as you eliminate the trigonometric function from your work, be certain to include the specific solutions within the interval. Here, it's not only the one that you will be getting is the final answer, but there would be certain or additional answers for your solutions. Check your answers for extraneous solutions, always based on the original statement of the problem. This can help in any equation containing a tangent, cotangent, secant, and cosecant in the original problem statement. Take note that even though you already answered or you already solved the solution, there are cases that extraneous solutions are part of the problem. Number 4, try using algebraic techniques to help you solve an equation before using any trigonometric manipulation. Factoring is incredibly useful in solving equations. Also, if algebra does not work to help you solve the equation, try getting the equation into terms of a single trigonometric function. Pythagorean identities are often helpful in doing this. Let us start by solving a simple trigonometric equation. Let's try to solve 2 sine x minus 1 is equal to 0 in an interval of x is greater than or equal to 0 degrees but lesser than 360 degrees. Let's try to write first our original equation, that is 2 sine x minus 1 is equal to 0. Next, you may isolate the 2 sine x to the other side while transposing negative 1 to the other side, or that is addition property of equality. So that is 2 sine x is equal to 1. And then, you may divide each side by 2. That is 2 sine x divided by 2 and 1 divided by 2. Leaving we have sine x is equal to 1/2. Okay. In this case, we will get the inverse sine or the arc sine of each side of the equation. You may use your calculator in doing so. So just press shift sine, or we have the arc sine, that is sine raised to negative 1, or the inverse of sine x is equal to sine raised to negative 1, or the arc sine of 1/2. So the inverse of the arc cos or arc sine, inverse sine would be x is equal to, that is shift sine 1/2. Please use your calculator either in radian or in degree. But make sure your calculator is in degree modes for a degree angle. So that is 30-degree angle. So x is equal to 30 degrees. Or this is pi over 6 in radian. Since solution should be an interval of 0 degrees, or x is greater than 0 degrees but lesser than 360 degrees, we need to look for the other angles included in the given interval. In doing so, identify where sine function is positive. Why sine function is positive? Because here, 1/2 is positive. Since, again, we will use the concept of the signs. We have A, S, T, C. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In this case, sine is positive from quadrant 1 and quadrant 2. Since x is equal to 30 degrees is already in quadrant 1, we need to find an angle in quadrant 2 since sine is positive in quadrant 2 that has a reference angle of 30 degrees. So in quadrant 2, we'll just write an angle whose reference angle is 30 degrees. What is that angle? That is 150 degrees. Thus, our value of x are x is equal to 150 degrees and 30 degrees. That's how to solve a simple trigonometric equation using the concept of sine of a trigonometric function plus the reference angle. Let's proceed to second example. Let us solve for cosine squared x minus 1 is equal to 0 in an interval of x is greater than or equal to 0 degrees but lesser than 360 degrees. Let's write our given, that is 4 cosine squared x minus 1 is equal to 0. Applying the addition property of equality, we have 4 cosine squared x is equal to 1, and divide both sides by 4. So that is cosine squared x is equal to 1/4. Eliminating now the square here by extracting the root for both sides. So that is cosine x is equal to, we have two principal roots here. One is positive and the other one is negative. Square root of 1 is 1. Square root of 4 is 2. And then the process, again, get the inverse cos of each side of the equation. So that is cosine negative 1 of cosine x, and also cosine negative 1 of either positive and negative 1/2. So x is equal to cosine or arc cos of positive negative 1/2. Now let's try to separate that one. We have x is equal to cosine or arc cos of positive 1/2, and x is equal to cosine arc cos of negative 1/2. So that is x is equal to, for the positive one, that is shift cosine 1/2, that is 60 degrees, and x here is equal to 120 degrees. Again, let's look for the other pair where the cosine is positive. Let's use again the concept of ASTC, that is quadrant 1, 2, 3, and 4. Since in quadrant 1, 60 degrees is positive, so that is already in quadrant 1, and in quadrant 4, 60 degrees or cosine is positive. Thus, we will use the concept of 60 degrees as a reference angle. So this is 60 degrees in quadrant 4. We'll get this portion. So that is 360 minus 60, that is 300 degrees. So the pair of 60 is 300 degrees. On the other hand, cosine is negative in quadrant 2 and quadrant 3. In this case now, 120 degrees is in quadrant 2. So all we have to do is to get quadrant 3. In quadrant 3, we will not use the reference angle of 120. However, if we will draw now 120 in quadrant 2, its reference angle is 60 degrees. So we will use again 60 degrees in quadrant 3 as a reference angle. So 60 degrees here. And we will get the whole angle in quadrant 3. So that is 180 plus 60 is equivalent to 240 degrees. Thus, our values of x are 60 degrees, 120 degrees, 240 degrees, and 300 degrees. Once you will substitute all this one in our values, it would be equal to 0. For the next example, we have solved sine squared x times cosine x is equal to 4 cosine x in an interval of x is greater than 0 degrees but lesser than 360 degrees. In this case, we will use now factoring to solve trigonometric equation. Remember not to divide both sides of an equation by the variable expressor such as cosine x. It will change now the value if you will do so. So in here, rewrite the original equation, sine squared x cosine x is equal to 4 cosine x. We may subtract both 4 cosine x from each side or simply transpose. So that is sine squared x cosine x minus 4 cosine x is equal to 0. Now let's factor out cosine x since it's common to both of the term. So that is cosine x times sine squared x minus 4 is equal to 0. Still, we need to factor this one into a sum and difference. So that is cosine x times sine x minus 2 times sine x plus 2 is equal to 0. Now, apply the zero principal property of equality where you could make cosine x is equal to 0, sine x minus 2 is equal to 0, and sine x plus 2 is equal to 0. So applying the arc cos or the inverse cos, so cosine negative 1 of cosine x, also cosine raised to negative 1 of 0, so x is equal to 90 degrees, and also where 0 of a value aside from 90 degrees is 270 degrees. So here we have sine x is equal to 2 and then sine x is equal to negative 2. Because neither sine x is equal to 2 nor sine x is equal to negative 2 has a solution, so this would become math error if you will do the calculator, or if you will do it in the calculator. Thus, the only solution from the interval 0 degrees or x is greater than or equal to 0 degrees but lesser than 360 degrees is 90 degrees and 270 degrees. In this portion, we will be placing or will be applying the concept of a unit circle that the maximum value only for sine and cosine, also the minimum value is from positive 1 and then negative 1. That's why there's no value for 2 and negative 2. Next one. This time, we'll solve an equation with an extraneous solution. Let's say we have 1 minus cosine x. So let's write our original equation. 1 minus cosine x is equal to the square root of 3 sine x. We need to solve in an interval of x is greater than or equal to 0 degrees but lesser than 360 degrees. In this case, to eliminate the square or the square root, let's square both sides. So that would become 1 minus cosine x quantity squared is equal to 3. So this will be cancelled out. 3 sine squared x. And then we'll expand the binomial. We have 1 minus 2 cosine x plus cosine squared x is equal to 3 sine squared x. In this portion, we could only have one trigonometric function. Thus, you may change either the cosine to sine or sine to cosine. In this case, sine squared theta or sine squared x is easier to transform into cosine using Pythagorean identity. So that is 3 times from the Pythagorean identity, sine squared x plus cosine squared x is equal to 1. You may transpose cosine x to the other side. That would be sine squared x would be 1 minus cosine squared x. And then we'll just copy 1 minus 2 cosine x plus cosine squared x. And then we'll distribute the term, or we'll multiply both terms by 3. So that is 3 minus 3 cosine squared x. And that would be 1 minus 2 cosine x plus cosine squared x. And then combine similar terms. So 3 would be placed here. So that would become negative 2, or that's negative 2 minus 2 cosine x, and then negative 3 would be placed there, plus 4 cosine squared x is equal to 0. Let's just arrange this one into a quadratic form. We have 4 cosine squared x minus 2 cosine x minus 2 is equal to 0. For easy factoring, you may divide this one by 2, all the terms. So that would become 2 cosine squared x minus cosine x minus 1 is equal to 0. And then we could factor this one into 2 cosine x plus 1 times cosine x minus 1 is equal to 0. And then apply the zero principal property, which is 2 cosine x plus 1 is equal to 0. And then cosine x minus 1 is equal to 0 as well. And then solve. Transpose positive 1 to the other side. So that's 2 cosine x is equal to negative 1. Divide both sides by 2. So cosine x is equal to negative 1/2. And then getting each root or each our cos, inverse cos. So x is equal to cosine raised to the inverse of negative 1/2. So that is x is equal to 120 degrees and 240 degrees. And also here, we have cosine x is equal to 1. X is equal to 0 degrees. The apparent solution, x is equal to 240 degrees, does not check in the original equation. Thus, the only solutions in the interval x is greater than or equal to 0 degrees but lesser than 360 degrees is x is equal to 0 degrees, and the other one is x is equal to 120 degrees. So it's better to check extraneous solution before we will conclude now whether it's part of the solutions or not. Let's proceed to example number 4. Now let's use if the given cannot be factored out, we will use the quadratic formula. The quadratic formula states that if x is equal to, we have negative b plus minus square root of b squared minus 4ac over 2a. So we will use that one in this portion. Since the equation is in the form AU squared plus BU plus C is equal to 0, you can use the quadratic formula to solve for U or to solve for the value of X. So that is, in this case, that is AX squared plus BX plus, or BX plus C is equal to 0. So our A here is 1. Our B here is negative 4. And our C here is positive 1. So that is cosine X is equal to negative 4 times 4 is positive 4 plus minus, we have negative 4 squared minus 4 times our A times our C over, we have 2 times A, which is 1. So simplifying it further, we have 4 plus minus, we have 16 minus 4 is 12. Square root of 12 over 2. Or this is 2 plus minus square root of 3. Thus, we have cosine X is equal to 2 plus or minus square root of 3. Since we have two values here, we could separate that one into cosine X is equal to 2 plus square root of 3. And then we have cosine X is equal to 2 minus square root of 3. And then, this one is approximately 3.732, and this one is approximately 0.268. And then getting its arc cos, so here cosine X is approximately 3.732. Notice that this is greater than 1, so X is no solution here. While this portion, we have cosine X, X is equal to shift cos 0.268, we have 74.45 degrees. So we have that portion. So aside from that one, again, we will use the formula or the form ASTC, where quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Here, cosine is positive. So in quadrant 1, cosine is positive, while in quadrant 4, cosine is also positive. Thus, we will use the concept of reference angle. The reference of the angle of that one is 74.45. And then we'll get the whole angle. Thus, it is paired with 285.55 degrees. Now, if we will check this one in the equation, it is approximately 0 because it would be approximately 74.45 and 285.55. You may ask later with your teacher why it is not equal to exactly 0. The explanation for that one, since these are only approximates, it is also approximate to 0. So that's how to solve our trigonometric equation using quadratic formula. For the last example, in solving trigonometric equation, we will apply that one in solving worded problems. So the worded problem states that the number of hours in H of sunlight per day in Prescott, Arizona can be modeled by the formula H is equal to 2.325 sine pi over 6 times T minus 2.667 plus 112.55, where T could be measured in terms of months and T equals 0 represents January 1. The question is, on which days of the year are there 13 hours of sunlight in Prescott, Arizona? So let's try to understand first the problem. Here there are two variables where h now is the given number of hours and then t is the days or the months. First, the given is 13 hours. This is our h. Substitute 13 for h in the model and solve for t. So that is 13 is equal to 2.325 sine pi over 6 times t minus 2.667 plus 12.155. And then isolating the t by transposing first 12.155 to the other side. That's 13 minus 12.155 is equal to 2.325 sine pi over 6 times t minus 2.667. Simplifying it further, so this is 0.845 is equal to 2.325 sine pi over 6 times t minus 2.667. So we need to divide first is 1 by 2.325, both sides, 2.325, so this would be cancelled out. So this would become 0.363 is equal to sine pi over 6 t minus 2.667. Okay. Get the inverse of each sine or inverse sine of each side. So that would be sine of the inverse 0.363 and then we have sine or the inverse of sine pi over 6 times t minus 2.667. In this problem, make sure that your calculator is in radian mode before using the inverse sign because this is in terms of pi, not in terms of degrees. Now, another one to take note of this portion is that once you will get the inverse of sine of 0.363 of the sine inverse again of sine pi over 6 t minus 2.667, take note that there are two possible values using the concept of ASTC. Sine is positive, where sine is positive in quadrant 1 and in quadrant 2. Thus, the other angle should be in quadrant 2. Using the reference angle concept, the other angle is pi, which is 180, minus the inverse of 0.363 is equal to the inverse of sine pi over 6 times t minus 2.667. Okay, let's solve first the left side. So this would become the inverse of shift sign. Again, please make sure that your calculator is in radian mode. So this is 0.371 is equal to pi over 6 times t minus 2.667. We'll multiply both sides by 6 over pi so that we could eliminate 6 and pi. So that would be approximately, this should be approximately at 0.371 times 6 divided by pi. So that is approximately 0.709 is equal to t minus 2.667. And then transpose this one to the other side. So that is 0.709 plus 2.667 is equal to t. So we'll add 0.709 plus 2.667. So that is approximately 3.376, or let's say 3.38. Okay, so let's go back later to that one. In this case, we also need to solve this one. So this is pi minus 0.371 is equal to pi over 6 times t minus 2.667. So approximately, this is 2.771, and this would be pi over 6 times t minus 2.667. Same process as the other side. We'll multiply both sides by 6 over pi. So that would become 5.92. Sorry, that should be 5.292. That's t minus 2.667. And then, approximately t is equivalent to 7.96. What is the meaning of this one? Okay, since the time t of 3.38 represents 3 full months plus 0.38 of 30 days, approximately 30 days, so that is approximately 11 days. So, January 1, that's 3 full months and 11 days from January 1. That is approximately April 11. Same goes with the time t. 7.96 represents 7 full months and 0.96 times 30 days. So that is 29 days. So that's 7 months and 29 days. So approximately that is August 29. Thus, the days where the year there are 13 hours of sunlight in Prescott are April 11 and August 29. So I hope the lecture helped us understand trigonometric equation and worded problem. Thank you and happy learning, STEM students. Again, this is Sir Jonathan C. Iglesias.